Good morning, all of you. Yesterday we saw Raoults law, that is liquid in liquid. Both the liquids are volatile liquids. We mixed two volatile liquids and we closed it. From each component, the vapors were coming up. Since it was a closed vessel, after some time an equilibrium will be reached. There is a vapor phase which contains two components A and B. The mole fraction of each component A and B, that is Ya and Yb in vapor phase. In the solution also there are mole fractions Xa and Xb. Xa and Xa plus Xb is equal to 1, that is in the solution, liquid solution. Ya and Ya plus Yb is equal to 1, that is in the vapor phase. Now in this equilibrium condition, we stated Raoult's law, which states that for a mixture of volatile liquids, the partial pressure of each component, that is Pa and Pb, partial pressure of each component is directly proportional to its mole fraction in the solution. Partial pressure of each component. Pressure stands for gaseous state. So in the vapor, in that mixture, vapor mixture, there is a partial pressure for each component Pa and Pb. Ya and Yb are the mole fractions, but Pa and Pb in the vapor phase, these are the partial pressures. Partial pressure of each component is directly proportional to its mole fraction in the solution. That is, Pa is proportional to Xa, Pa is equal to P naught A Xa, where P naught A is the vapor pressure of the pure component when that pure component is taken in the same vessel separately, individually, in that closed vessel. P naught A is the vapor pressure of the pure component, that is not the mixture. Similarly, Pb is proportional to Xb or Pb is equal to P naught B Xb. P naught B is the vapor pressure of the pure component when that pure component is taken alone in the same vessel separately. So Raoult's law, the mathematical expression for Raoult's law, Pa is equal to P naught A Xa, Pb is equal to P naught B Xb. Let's see the numericals based on this. All the three vessels are of equal size. And this black one, that is the pure solvent or one pure liquid. Here component A, that is black one, that is less volatile, means very less number of, you can see very less number of black in the vapor phase. But here red one, it is highly volatile. It is highly volatile. More and more vapors you see in the vapor phase. Pure vapor pressure of A is called P naught A. Pure vapor pressure of B is called P naught B. But in the mixture, that is on the top, in the mixture, we have PA, PA and PB. That is the vapor pressure of each component in the mixture. We know that PA plus PB is equal to P total. P total is equal to PA plus PB. Now, there is an XA, there is an XB. What is XA? XA is the mole fraction in the solution. XB is the mole fraction in the solution. Now, what is Raoults law? Raoults law is equal to Raoults law, that is PA PA is equal to P naught A into XA. And that side, PB is equal to P naught B into XB. This is Raoults law. PB is equal to P naught B into PB is equal to P naught B into XB. Now, there is a YA. What is YA? YA is the mole fraction. YA is the mole fraction in the vapor phase of component A, and YB is the mole fraction of the component B. YB is the mole fraction of the component B in vapor phase. Now, Raoults law states that for a solution of, or for a mixture, for a solution of volatile liquids, the partial pressure of each component the partial pressure of each component is directly proportional to x, its mole fraction in the solution. See, its mole fraction in the solution. Pt is equal to Pa plus Pb, that is according to Dalton's law. And Pa is equal to Pa is equal to YAP total. That yesterday also we saw Pa is equal to YAP total. That is partial pressure, that is individual pressure is equal to mole fraction of that component in vapor phase into the total pressure. Now, that side, that is PB is equal to PB is equal to YBP total. So we have 5 equations here. Pa is equal to P naught AXA. See, Pa is equal to P naught AXA. Pa is equal to P naught AXA. Pb is equal to P naught BXB. Pa is equal to P naught AXA. Pb is equal to P naught BXB. Pa is equal to YAP total. Pb is equal to YBP total. Pt is equal to Pa plus Pb. You have to take care that this P naught A, when we write this P naught A, when the pure component A is taken in the same vessel, same vessel, same vessel. What is P naught B? That is the vapor pressure of the pure component B, and this is always considered as highly volatile, means its vapor pressure will be higher. B is the component. Suppose, yesterday I told you, suppose we are considering this B is highly volatile. When B is highly volatile, that means it exists in the vapor phase. And A is low volatile, means that will be existing in the form of liquid only. So one liquid and one gas, similar to Henry's law. Similar to Henry's law. So what is Raoults law? Raoults law is P is equal to P naught AXA, PB is equal to P naught BXB. Now, suppose this is highly volatile, that means here only that PB will be there, PA will not be there. So this will not be that, that is P naught AXA, that P naught AXA will not, PA is equal to P naught AXA will not exist. What exists is PB is equal to P naught BXB. That is a condition, a special case. See, Raoults law is PA is equal to P naught AXA, PB is equal to P naught BXB. Suppose you consider this PB is very highly, this a B component is highly volatile, that it exists only in the vapor phase, just like carbon dioxide, and here it is water. Now what happens? This does not exist. Only this exists in that condition, because this we have considered as non-volatile and this is highly volatile. So in that case, Pb is equal to P naught Bxb exists. And on the previous day we learned Henry's law, that is Pb is equal to Kh into Xb. There also we considered one gas and one liquid. But you see, this P naught B differs from KH. Here it is P naught B, there it is KH. P naught B, in these two equations, P naught B differs from KH. When P naught B becomes equal to KH, then this Raoults law becomes a special case of Henry's law. Then the Raoults law becomes a special case of Henry's law. Now here we have to see five equations. One is PA is equal to P naught AX, Raoults law. PB is equal to P naught BXB. Then P is equal to YAP total. PB is equal to YBP total. Then PA plus PB is equal to P total. So equation number 1, equation number 2, equation number 3, equation number 4, equation number 5. So there are 5 equations when we consider this Raoults law. Raoults law is that equations are 1 and 2 only. 3 and 4 last year we learned, 5 also last year we learned according to Dalton's law. According to Dalton's law. Now let's see the numericals based on this vapor pressure. Question: vapor pressure of CHCl3 and CH2Cl2. One is chloroform, means trichloromethane, and the other is dichloromethane at 298 Kelvin or 200 mmHg and 415 mmHg respectively. Now in this case you can see that this is heavier than this. That means this will be in the vapor state. This will be more in the vapor state. So its vapor pressure will be high. Pure components, its vapor pressure. Pure CH2, Cl2 components vapor pressure will be higher. See, 415. This is only 200. CHCl3 is P0A, that is 200. And this is CH2Cl2, that is 415. Pure components, that is higher respectively. Calculate the vapor pressure of the solution prepared by mixing 25.5 gram of CHCl3 and 40 gram of CH2Cl2 at 298 Kelvin and the mole fraction of each component mole fraction of each component in vapor phase. This is the question. Vapor pressure of CHCl3, that is 200, CH2Cl2, that is 450. Calculate the vapor pressure of the solution prepared by mixing. Calculate the vapor pressure of the solution. See, the question is calculate the vapor pressure of the solution, that is P total, prepared by mixing so and so. Vapor pressure of the solution, that is P total, we have to find out. What is P total? P total is equal to, we can derive an equation, that is P total is equal to PA plus PB. That is PA according to Raoults law, P naught A XA plus P naught B XB. P naught A is given, P naught B is given, XA and XB you can find out. XA and XB you can find out from this 25.5 and 40. From this you can find out this XA and XB. You find out only this only XA or XB, one minus that will give the other one. Or we can make a new equation also from this, that is this XA we are going to convert that in terms of XB, that is P naught A into 1 minus XB plus P naught B XB, which is equal to P naught A minus P naught A XB plus P naught B XB, which is equal to P naught A. Now P naught B minus P naught A, that is P naught B minus P naught A into XB. So P naught A plus P naught B minus P naught A. So PT is equal to P naught A plus PT is equal to P naught A plus P naught B minus P naught A into XB. Once again, P total is equal to, I have written PT in terms of two pure components vapor pressures, pure vapor pressure into XB, that is only one of the mole fraction of the solute, only one mole fraction. In this you won't find XA. So you have to find out only this XB. This is given, this is given. This is also given, means because these two things are same. Now XB. So PT is equal to P total, we have to find out PT is equal to P naught A plus P naught B minus P naught A into XB. So we have written an equation in which only one mole fraction in the solution, that is only XB. Only one mole fraction you can find out. See, this is given, P naught A is given, P naught B is given, XB you have to find out. How will you find out XB? So I am going to find out XB. XB is equal to NB upon NA plus NB. NB, what is NB? 40 divided by its molar mass, that is 85, divided by then 40 40 divided by 85 plus 25.5 divided by 119.5. You have to calculate the molecular masses by right from CHCl3. What is CHCl3? CHCl3 is carbon, hydrogen, 3 chlorines, and in CH2Cl2, carbon, 2 hydrogens, and 2 chlorines. So, you can calculate here, you can calculate the molecular mass, and given mass upon molar mass will give you the number of moles. So, XB, you can calculate it as XB is equal to, anyway, it is less than 1, and we get it as 0.688. So this value you substitute here for this XB. This value you substitute here for XB. So I'm finding out P total. P naught A. What is P naught A? 200 plus. What is P naught B? 415 then minus 200 into 0.688. You are getting it as 347.9 mmHg. So P total, first portion is over. What is the first portion? Calculate the vapor pressure of the solution. This much portion is over. Calculate the vapor pressure of the solution. That is over. Now what you have to find out? Mole fraction of each component in vapor phase, that is Ya and Yb. Ya and Yb. Ya and Yb. One you calculate, other you can take from 1 minus the, suppose you are calculating for Ya, then 1 minus Ya will give you Yb. But Ya we have to calculate. How can we calculate Ya? Which is the equation including Ya? Among those 5 equations, where did you see Ya? That is, Pa is equal to Ya P total, or Pb is equal to Yb P total. Pb is equal to Yb P total. P total we know, just now we have calculated this P total. Yb we have to, so this is obtained. Yb you have to calculate. So we need what? Pb. Pb is equal to P naught B XB. That we know. Pb is equal to P naught B XB. So Pb, how can we calculate Pb? Pb is equal to P naught B XB. XB here 0.688. What is P naught B? That is that higher value, 415. So I'll write Pb is equal to P naught B into XB 0.688. Right? So here 415 into 0.688 is equal to Yb into P total, that is 347.9. So you can calculate what this Yb, you can calculate that Yb is equal to 415 into 0.688 divided by 347.9. So you got some answer for this, that is Yb. Yb is equal to anyway that will be a quantity less than 1, 0.82. Now what is Ya? 1 minus this will give you Ya. Ya is equal to 1 minus 0.82, that is 0.18. that is 0.18. 0.18. That is how we do the calculation. So PT, this equation you have to by heart, which equation? PT is equal to P naught A, that is the vapor pressure of pure component, plus P naught B, vapor pressure of pure component, other component, vapor pressure of other pure component, that is P naught B, minus this P naught A and only one mole fraction. Or you can express this P total in terms of one mole fraction. You can express this P total. Now you see this is in the form of y is equal to mx plus c. Let's analyze this equation. That is P total is equal to P naught A plus P naught B minus P naught A into XB. So this is equal to y is equal to mx plus c. Y is equal to mx plus c. So if we plot a graph between, this vapor pressure, means vapor pressure of different mixtures against its mole fraction. What is the mole fraction? XB. So if I take, if I plot a graph between vapor pressure vapor pressure and the mole fractions. Mole fractions means you can consider here in this end only XA is present, that is XA is equal to 1. So that time XB is equal to 0. Only one component is present. And that side XB is equal to 1. That means only B component is present. That time XA is equal to 0. You can consider mole fractions at different, that is here 1, then little less, that is 0.8, then 0.6, then 0.4, then 0.2, then x is equal to 0, that's it. Or here if you are increasing xb, that is 0.2, zero point 0.2, then 0.4, then 0.6, then 0.8, then xb is equal to this 1. So in this case, we are going to mark this P total. What is P total? P total we see y is equal to mx plus c. There is a y-intercept, that is c. So you will be getting a straight line with that y-intercept. So this is like this. This is P total. P total is equal to PA plus PB. You are taking different mixtures. Here one mixture means here it is, okay. Here one mixture and here one mixture, here one mixture, here another mixture. Means we are changing the mole fractions. So different solutions are there. So you see, now in this way, that is in this way, XA is decreasing, XA is decreasing. See, XA is equal to 1, then 0.8, 0.6, zero point 0.4, zero point 0.2. So XA is decreasing. We know that PA is equal to PA is equal to P naught A XA. XA is decreasing, so PA is also decreasing. So the graph is like this. So this is PA. This is PA. Now, you consider this one. In this, XB is increasing, XB is increasing, and here PB is equal to P naught B XB. P naught B XB. So XB is increasing, so the graph is going. So it is increasing. So this is PB, and the blue one is PA. Red one, that is on the top, that is PT is equal to PA plus PB. And what is on that top, that is this one is P naught B. P naught B, always we take it as higher because B is considered as high volatile. And here this is P naught A. So here it is P naught A, there it is P naught B. P naught A is higher here, P naught B is higher here. For the black line, the highest is P naught B, and for the blue it is highest is P naught A, that is a pure component. The pure component. When you consider only A, see A, the concentration A, see here 0.8, 0.6, 0.4, 0.2, then 0. Now here 0, that is XA is 0. XA 0 means that A component is not present there. A component is not present there means the vapor pressure due to that is 0. Similarly, at this point only P naught B is there. When we come here means XB. See, XB is 0. That means that component is not there. So the vapor pressure due to that component is 0. Now here only XB is there. That means that is a pure vapor pressure. Here only XA is there. That means its vapor pressure is that pure vapor pressure. B component is not there. So the total vapor pressure here is P naught A. Total vapor pressure here is P naught B. Here total vapor pressure is P naught A. Here total vapor pressure is P naught B. Here is the P total. Here is the P total. So this is the graph, total graph for all these things. So we have different mixtures in which, see in this mixture only A is there, in this mixture little bit B is there, in this mixture little more B is there. So accordingly the mole fraction of A will be less. Here little bit more, accordingly the mole fraction of A is less. And here B little more, and here B is full. B is full. So that time A is not there. So in this case, vapor pressure, total vapor pressure is only due to A. In this case, see, mole fraction of A is getting less. Mole fraction of A is getting less. Accordingly, PA decreases. See, this PA, this value, this is the highest, and this value. And in this case, again, mole fraction of A is decreasing. So accordingly, A is this. XA is decreasing, so PA is decreasing. In this case, mole fraction of XA, mole fraction of A is decreasing, so accordingly, see, zero point 0.4 only, so accordingly PA here again decreasing, so accordingly, so here A is 0. Now in this case, here XB that is 0. We can start from here. XB is 1 means pure vapor pressure. Now in this mixture, it is less. Here it is 1, it is less. That means accordingly the vapor pressure decreasing. And in this mixture from 0.8 to 0.6 it is decreasing. So PB is decreasing. In this mixture 0.4 again less. So it is here. In this mixture XB is, so the point is here. And in this mixture no XB, so no PB. PB is equal to 0. So these things are there to do the numericals. I am stopping here. Thank you.